Hello, this is Siksha Vinaya, and I am going to deliver the lecture about the kinematics for study 9, part 6. In the previous lecture, I have dealt about the kind of motion that is uniform and non-uniform. I am here to deal about how you solve the problems involving this kind of motion for greater numerical ability skill. So in this lecture, I am giving you the idea how to solve, how to express the quantities in kinematics. You have already know the idea of acceleration, which can be written mathematically as a is equal to v minus u upon t. But if you manage this expression or manipulate its expression by mathematical methods, then you can solve it here using cross multiplication. V minus u must be equal to a into t, and if by transposition it must be, you get v is equal to u plus at. It means this is a new expression. So for the same expression which is given by the definition of acceleration, you can find out the expression for velocity. In the similar manner, if you manipulate this expression, you can find out the relation for time. And the similar way you can find out the relation of u by this relation alone. Have you got my point? By some manipulation or mathematical process. So what I am going to deal here is, if three things are known, means let us say if u, a, t are known, u, a, t, three physical quantities are known, then you can find the fourth quantity by using relation. That means b is the unknown quantity or fourth quantity. You can find out by the relation if the three quantities have already known in the problem. Have you got my point? So if v is not known but u, a and t are given or known, then you can find the v by the relation here I have already written. V is equal to u plus at. But if v, u and t are given, how can you find a? It is simply by the relation. You already know about it. A is equal to v minus u by t. In the similar way, if v, a and u are given, you can find out t. You can express t in terms of v, a and u. This is the merit of this expression, this single expression. Whatever is given in your question, you observe that which quantities are known, and then observe that which quantity you have to find out or which quantity is unknown. then the unknown quantity can be expressed in the relationship as I have told you here. Now, so if you have tried, you must got these relation. B is equal to U plus AT in terms of U, A and T, B can be known. In terms of B, U, T, A can be known. And in terms of B, U, A, T can be known. Now I am giving you a problem for your greater understanding. A biker starts a bike which is from rest and accelerate it by 2 meter per second square from rest. It is given here rest. If rest is not written in the problem, you have to take it is at rest. Have you got my point? So what will be the velocity after 5 seconds? So what are the information or quantities given here? You have to observe first. Then you have to observe which quantities are unknown or which quantity are to be find out. So here, if a biker starts from that, it means initial speed or velocity is 0. That's why I'm writing symbol u is equal to 0. So you have to write given and u is equal to 0. Now what is given? Accelerate it by 2 meter per second square, means rate is or acceleration is here 2 meter per second square. It means A is here 2 meter per second square. Now what will be the velocity after 5 seconds? Means you have to take time interval as 5 seconds. Now what is unknown here? The final velocity at 5 seconds. Have you got my point? Means B is unknown here. You can solve it by using formula B is equal to U plus AT and putting these values in the equation. You can solve your problem. Now I am giving you another problem for you. I changes some of the information which are given in previous case. Here in the previous case, what would be the acceleration after 5 seconds if it comes at rest in 20 seconds? You have understood the problem, that in the previous case a biker start from here at rest and move for 5 seconds at the rate of 2 meter per second square. So in the previous case we have already find that the velocity at after 5 seconds, just after 5 seconds, is 10 meter per second. Have you got the result in the previous case? If you have done your job, then you get the answer is 10 meter per second in the previous case. So after 5 seconds, the velocity is here is 10 meter per second. Now he now move for another 20 seconds. But he slows down his bike and ultimately come to a rest after 20 seconds. So what will the acceleration during this period of motion? Can you find it? So what is the information? What is the information given here? Simply here from this to this point, u is 10 meter per second. For the previous case it is final velocity, but for this case it is initial. So a speed may be initial, may be final. It is the matter of situation. So if you take the motion during this to this, it must be your final speed velocity. Or if you take the motion during this to this, it must be your initial velocity. Have you got my point? So that's why here u is 10 meter per second, v is 0 because it ultimately comes at rest in 20 seconds. That means final velocity must be 0 and the time taken is 20 seconds. You have to find out the rate, means acceleration. If you solve it by using expression I have already given you, that you must get the answer as minus 0.5 meter per second. What you observe from this answer? The answer is negative. Why it is negative? Because from this to this its speed decreases. That's why acceleration is negative. Means negative acceleration signifies that the speed decreases. Have you got my point? That's why it is called as a special name, retardation or deceleration. Have you got my point? So what you have learned in these two cases, from these two cases, is in the first case you got positive acceleration, but in the second case you got negative acceleration. So positive and negative acceleration gives the idea about velocity increases for positive acceleration. It is also called speeding up, means velocity increases or speed increases, or you can say in your common language the object is become faster. And a similar way, if negative acceleration comes, means velocity decreases, speeding down, or the object become slower. Have you got my point? This is not hard, this is simply easy. Now, what is the meaning of applying brakes or giving jerks? You have already know that if you go to your school, somewhere the driver applies some brakes and the bus decreases its speed. Yes or not? Or ultimately come to a rest. Yes or not? It means brakes means to brake a speed, and whenever brakes applied, its speed becomes slower, or it becomes lower than the previous one. So velocity decreases. So final velocity always less than initial velocity because its speed decreases. Have you got my point? So v less than u. U is greater, v is lesser. So v is less than u. So in this case, if you apply brakes, in this case a must be negative, I have already told you. So it is retardation and object ultimately at stops. But in the case of jerks, velocity may changes, either faster or slower. It depends on jerk. If the jerk is given in the same direction as the bus is moving, then the speed is increases. If the jerk is given in opposite direction, the bus decreases its speed. It depends on the situation. So jerk may increase the speed of the object or may decrease the speed of the object. So in this case a may be positive, a may be negative as per the situation which is given in the problem. So what do you mean by the when velocity is constant or uniform? I have already told you in the previous lecture that if the velocity is constant, means at every place or every point of instant the velocity is same, means v is same as u. So acceleration must be 0 because there is no change in speed. By the definition, acceleration is the rate of change in speed, but here is no change in speed, no change in velocity. That's why acceleration is 0. No acceleration, and this kind of motion is called uniform. motion. So in uniform motion, uh, you can say if speed is constant at every point, you already know about in the previous classes. How can you find out distance or if a speed and time is given? You simply say that a distance is equal to speed into time. You have already known about it in the previous classes. How can you find the distance? If a man walk with 20 meter per second for time 2 seconds, then what will be the distance he covers in 2 seconds? It is simply, you can say, distance is equal to speed into time. That's why it is 20 into 2 means 40 meter. So in uniform motion, the formula for displacement must be velocity into time or initial velocity time, because v is same as u. That means displacement is equal to speed into time, velocity into time, v into t. This is the relationship in the uniform motion. I have given you a problem that if a cyclist move with 20 meter per second, and what is the displacement covered in 40 seconds? I have already told you how to solve it. You know about it in the previous class. Have you got it? But if we take non-uniform motion, what will happen? If you take non-uniform motion, what will happen? In your class, you must assume that acceleration is constant everywhere, because this is a simpler case for non-uniform motion or accelerated motion. Otherwise it may be complex. You will deal it about this kind of problem when acceleration changes time to time in 11th class. But in your class you only deal about the non-uniform motion when acceleration is fixed or constant. So for simpler cases or for your class, a is same or a is fixed or constant if the motion is accelerated or non-uniform. So I give you a problem, you can think about it. If a cyclist increases its velocity at the rate of 2 meter per second square from rest, what would be the displacement covered by him in 40 seconds? What will be the answer? Can you solve it by your some mathematical skill or by common sense, whatever they are? You must solve it. How can you solve it? And what is the meaning of this question? What is the observation you get from this question? So I am giving you some hint here for this question. This question say that the cyclist increases its velocity at the rate of 2 meter per second from rest. Means acceleration is here 2 meter per second square. It also means that from rest, after each 1 second, its velocity changes to 2 meter per second, because the acceleration is nothing but rate of change of velocity. Means the acceleration is means the change in velocity in 1 second. It means in 1 second the velocity changes by 2 meter per second. Have you got my point? So I have given you here by the diagram that for 1 second its speed, or here acceleration is positive, that means it increases. So for 1 second the velocity increased by 2 meter per second, means the velocity after 1 second is 2 meter per second. And now another for 1 second it also increases by 2 meter per second, means after 2 seconds its velocity becomes 4 meter per second, and so on. And after 40 seconds its velocity becomes 80 meter per second. This is the observation you get from the question, that what is the meaning of acceleration in the practical situation. This is the real meaning. Are you clear? So if you understood my point, then what will be the length of AB, or displacement in this case? Can you find it yourself? I am giving you an answer about it. 1.6 kilometer or 1600 meter. You can write it out at your home. Now I am giving you another problem for your practice. I am giving you TAH problem, that means try at home problem. You have to solve it by yourself. Here you can write the problem in your notebook and try to solve it by yourself. Here is the problem. Now at last I am giving you another problem. Just try it and ask me questions. Think about it, because physics without thinking is useless. So motivate yourself. You must have guts to solve the problem or think about the situation. Just try it hard. That gives you strength inside you. Feel confidence. You must feel confidence after getting the answer by yourself. In the next lecture I must give the more idea about the motion. So for today, thank you for watching.